multiply. So because there's an equal sign right in the middle and there's a fraction on each side, we are going to cross multiply, which it looks like a butterfly. Some of you might notice it looks like a butterfly because this is probably how your elementary school teacher taught you how to do it. You're making a butterfly using cross multiplication. So I'm going to do 10 times 9. Is equal to the top and the bottom being multiplied together also. So I'm going to kind of go back and forth. It's like a little crisscross. So this is called cross multiplication. It makes a beautiful little butterfly. 20 times 2x minus 9. Does anybody remember, or does this look familiar to you at all? Yeah, okay. So it doesn't matter if the 9 or the 10 goes first. It does not matter if the 20 or the 2x minus 9 goes first. I usually just do top to bottom. But if you put them opposite, you're going to get the same answer because either way you are multiplying, either way you're distributing, you're going to get the same answer. So 10 times 9 is 90. And then over here, I have 20 times 2x minus 9. Because there's two terms in this parentheses, I'm going to have to distribute, okay? So I'm doing 20 times 2x and 20 times 9. So 20 times 2x is 40x. 20 times 9 is going to be 180, so minus 180. And now it's just like a two-step equation that we've done in the past. So what should I do to both sides? Add 180 to both sides. So 90 plus 180 makes 270 equals 40x. And then last step, what do I have to do? Divide by 40. Whose music is that? Isaiah. Yeah. Okay, so we're going to do the same thing on the other side. So for the other equation, and you will get decimal sometimes, so this is decimal, okay. Over here, we're going to do the same thing. We are cross multiplying. This is just kind of warming you up. Algebra is here's the equation, solve the equation. Geometry, you're going to have to set up this equation and then solve it, okay? So we're going to do the same thing. We're going to cross multiply. So I'm doing top times bottom. So I'm going to do 12 times 15 equals, and then I'm doing top times bottom. And then you could technically put the 18 in the front or you could put it in the back. It does not matter. Just because I'm doing top times bottom, I'm going to do 3x plus 4 times 18. So if you switch these two terms, it would be a lot easier on your eyes because you're going to have to distribute, but you're going to have to distribute backwards. But it's okay because if you put the 18 in the front or in the back, you're going to get the same answer. You just need to know that you're distributing still. So if I do 12 times 15, what am I bringing down? 180, perfect. And then equals, and then this time I have to distribute 18, but I'm going to kind of have to like work backwards. It's a little weird, but it's okay. 18 is going to be multiplied by 3x. 18 is also going to be multiplied by 4. So what is 3x times 18? 54x plus, and then 18 times 4 is going to bring down 72. Oop. Okay. So I have two terms on each side, and this is just like before. What am I going to do to both sides? Minus 72, and then divide. Minus 72. So I get 108 equals 54. And then I have to divide. So what do you end up getting as your answer? 2. Okay. So that is what we're going to have to do on the back side of this. Okay, so be prepared. But we're going to have to set up our proportions. So we're going to fill in some like vocabulary. So down here it says, what is a proportion? So these technically are proportions. It's comparing two ratios. So it's an equation that states that two ratios are equal. So this is ratios. A ratio is just a fraction. A proportion is written as a fraction on each side with an equal sign in the middle. So if I do A, this, for example, A over B equals C over D. So these would just be numbers and variables and whatever. Okay, so that's how it's going to be set up. Fraction, equal sign, fraction. Cross product property is cross multiplication. Product means multiply. So for any proportion, you're always taking the top and you're multiplying by the bottom. So I could do A times D equals C times B. So you're always taking the top, multiplying by the bottom, taking the top, multiplying by the bottom, and it doesn't really matter the order. You can flip-flop these as long as you're multiplying, doesn't matter. For similar polygons, so we've talked about congruent polygons. Congruent shapes is whenever they're exactly the same and they're just moving across and they look exactly the same shape, same size, everything is the same. Similar is the same shape, just a different size. So like yesterday. So polygons with the same angles, but they are different size. So we talked about an equilateral triangle yesterday in yesterday's bell work. If it was a small equilateral triangle, each corner would be 60 degrees if it was a little baby triangle, okay? If it was a bigger equilateral triangle, it's still gonna have 60 degrees on the inside. The measures don't change on the inside of the shape. The lengths of the sides are gonna change. So polygons are similar if corresponding angles are congruent. Or congruent. So if they are corresponding means the same like location, same spot, the same angles are congruent. Remember, this is the congruency symbol. You have an equal sign with a squiggle on top, okay? And then the second thing is corresponding sides are proportional. The corresponding sides are proportional. The ratio of the corresponding sides is called the scale factor, which we talked about yesterday. Yesterday, we talked about scale factors. We talked about if a scale factor is less than 1, it gets smaller. If it's more than 1, it gets bigger. And the last thing is if polygons are similar, then their perimeters are also proportional. Blech. Okay. So below we have 2 similar triangles. A congruency statement is just like this symbol. It has the equal sign with the squiggle. Okay, so that means they're literally identical. They are the same. So if what perimeters. So congruency symbol looks like this. If 2 triangles are similar, they also have a symbol. Their symbol is just a little squiggle, no equal sign underneath it. So for example, if I said that triangle ABC is similar to the other triangle, because notice that they have the same angles. I have 1 arc mark, 1 arc mark, 2 arc marks, 2 arc marks, and 3 and 3. So these are similar. They have the same angle measures, but they are not the same size. This one clearly is smaller. This one's clearly bigger, okay? If I say ABC is similar to the other triangle, and if I say A has to go first, what letter would have to go first? What letter matches with A on the bigger triangle? D. And then I put B in the middle. B has 2 arc marks. What's that going to match with? E. And then what would have to be the last one? F. The way that these are written is going to help you. So if A goes first, that matches with D. If B goes second, it matches with E. And C goes last, it matches with F, just like when we did the congruency. So now we're going to talk about scale factors. So scale factors are measuring the sides. I want to know how much bigger it is than the other shape from ABC to DEF. So if I start at A, BC, and I go to DEF, am I getting bigger or am I getting smaller? I'm getting bigger. So what I'm going to do is I'm going to start with ABC's triangle. I'm going to pick a side. So let's just use 8. Boop, 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 boop. So if I have 8, what side would match with 8 on the larger triangle? 12. Can I simplify this fraction? What goes into 8 and into 12? 4. So if I divide by 4 to both of them, that makes my scale factor as 2/3. We're going to do the same thing, but we're going to do it the opposite way. It says, what is the scale factor from DEF to ABC? So if I start with DEF first, that's going to be the top number. So let's use, I don't know, 27. So if I say 27 divided by something on ABC, what matches with 27? 18. What goes into 27 and also goes into 18? 9. So if I divide by 9 to both of these, what is that going to reduce to? 3/2. So if they say it as ABC to DEF, it's 2/3. If you work the opposite way, it's the same fraction, just flipped. So instead of 2/3, now it's 3/2. We're going to do the ratio of the perimeter of DEF to ABC. So specifically, we have to use DEF first. So if I'm talking about the perimeter of this shape, the perimeter means I add up all the sides. In a calculator, if you add these up, what is the perimeter of the big triangle? Anybody with a calculator? 54. And if I find the perimeter of the small one and I add them up, you end up getting 36. So I'm going to do the same thing. I'm going to take my big triangle and I'm going to divide by my small triangle. So if I do 54/36 and I reduce that, that's also going to reduce to 3/2. So whatever the scale factor is, it's also the ratio for the perimeter because those fractions are all going to reduce the same. If I put it the opposite way, if I said triangle ABC to DEF, then it would be 2/3 because it says DEF first, it's 3/2. Okay. On the back is where we're actually going to set up proportions and we're going to solve them. So on the back, we're going to start with number, which one did I start with? 5. So looking at number 5, we have to set up, this is what we're trying to set up. We're trying to set up something that you can cross multiply to solve for X. So if I look at number 5, it gives me a similarity statement. This is going to help me. We're going to compare the big triangle to the small triangle. So we have to find matching pieces. So the first thing I want you to do is we're going to look at the big triangle and I'm just going to pick one of the sides. So this is the big one. This is the small one. I'm going to pick one of the sides. I'm going to say, I'm looking at this right here. 6x plus 3. This is D to E. If I look at D to E is the last 2 letters in this statement. So the last 2 letters on this other statement are going to match that. So D to E matches with G to E. So if I look to G to E on my picture, what is that going to match with? Is it going to match with 21 or 17? 17. So these pieces match. So that's where I'm going to start. Your proportion is going to be big triangle divided by small triangle. That's going to be like the formula that you're using. So I'm going to start with the big, which is 6x plus 3. Divided by its matching small piece, which is 17. I'm going to put an equal sign in the middle. And now I'm looking for the next half of the proportion. So if I'm looking at my big triangle, I'm going from C to E. C to E is from here to here. C to E is the first letter and the last letter. So it needs to match with F to E, the first and last letter of the second one, which is 21. I'm going to always do big divided by small. So I did 6x plus 3 divided by 17 because this was the big piece compared to the small piece. And now I'm going to do big piece compared to small piece. So what is going to go on top? Is it going to be 21 or 8x minus 1? 8x minus 1 because the big triangle needs to be on top. And now I have a problem just like I had in the very beginning. I'm going to start by cross multiplying top to bottom and then putting an equal sign and then top to bottom. So I'm doing 6x plus 3 times 21. Which one do you want to write first? Do you want to put 6x plus 3 first? Or 21 first? 21? Okay, let's put 21 in the front. Do you know why that makes sense? The reason why she probably chose to put 21 in the front and back was only because you have to distribute. If you put it the opposite way, you still have to distribute, okay? So if you put the other part first, that's also okay. So now I'm going the opposite way. I'm multiplying these two. Which one do you think I should put in the front so I can distribute easier? The 17 or the 8x minus 1? 17. Okay, so now I can distribute nicely. So I'm going to do 21 times 6x, which is 126x. And then I'm going to do 21 times 3, which is 63. I'm going to do the same thing to the other equation. I'm distributing this time a 17. So I'm going to do 17 times 8, which is 136x. And then also 17 times minus 1, which is minus 17. And now it's just like a problem that we've been doing all year. So what do you want to do to both sides? Sure. So you could minus 63 or you could add 17. I'm going to add 17. I've had 126x plus 80 equals 136x. And then what do I have to do to both sides at this point? Subtract 126. Subtract 126. So I have 80, sorry, equals 10x. And then last step, I divide, and then you have your answer. So if I divide, so x equals 8. So from here, all this purple, that is stuff that we've been doing in class. You should be good with that. The new part is going to be setting up the proportion and then distributive property. Okay, so this is going to be the hardest part, is setting up your proportion. If your proportion's wrong, the equation is going to be wrong and everything else is going to be wrong. Okay, so we're going to set up another one together. So let's just go directly underneath it. Let's just go to number 6. Yes, take the pass. So number 6, same thing. I have two triangles. I have my big and I have my small. Yeah. So I have my big and I have my small. The most important part is finding the matching pieces. So try to pick one side and see if you can figure out which side it matches with on the small piece. So we're going straight under to number 6. Try to use your similarity statement. It says this triangle is similar to this triangle. Number 6, straight underneath. It doesn't matter which side you start with. If I choose to start with XY, which if you chose a different side, it does not matter. If I do XY, XY is the first two letters in the similarity statement. So what does XY have to match with on the other triangle? RS because they are the first two letters. The first two letters match with the other first two letters. So I have my big, and I'm going to divide it by my small. So I'm going to do 5x minus 3 over 3x plus 2. I'm going to put the equal sign in the middle. If you started by looking, by looking at the 60, which is fine, 60 is XZ. XZ is the first and the last letter, so it has to match with the first and the last letter on the second statement. So R to T would be right here. So I'm going to do 60 over 40. It's big divided by small. And if you flip-flop these, you could have 60 over 40 over here, and you can have this one over here. It just technically, it doesn't matter. There's a bunch of ways you could set up these proportions. Okay, so you're always doing big divided by small, equal sign in the middle. So try to cross multiply. See if you can multiply. Okay, so you should have something like this set up. These can be flip-flops. So you can have 40 last and 5x minus 3 in the front. You could switch these. You could also switch these. You could have 60 in the back, and you could have 3x plus 2 in the front. Doesn't matter. Either way, you're distributing into your parentheses. So 40 times 5x is 200x. 40 times 3 is 120. 60 times 3x is 180x. 60 times 2 is 120, 120. And then from this point on, it's just like everything we've done in this class. So now we're going to add 120 to both sides. Subtract 180. No. So you won't use N, and you won't. So pick one on your list. So you begin to here first one. So what would it match with? So you'll do 28 over 20. So I'm going to add 120 to both sides. 200x equals 180x plus 240. And then I'm going to minus 180 to both sides. Minus 180x. So you get 20x equals 240. Divide by 20. You get x equals 12.